So double integration is very similar to single variable integration. In this video I'm going to illustrate this property here. It's saying that when you have one region and then you add it to another region, so when you have one region R1, let's just say it looks like something like this, and then you've got another region R2, so this is R2 here, you can combine the two together into one big region. So this big region is this thing here. So I'm going to illustrate this because this thing here, hang on, this thing here is one region, and this thing here is another region, and then we're going to combine the two together into one big region. So let's start again. We've got a surface here, same surface, that's this surface here. And we need to understand the two regions. We need to understand the two regions. So let's try and sketch a graph. So this is x, this is y. Dx would mean that this would be x equals something, x equals something. The outer integral y would mean y equals something, y equals something. Same goes over here. It's going to be x equals something, x equals something. And then it's going to be y equals something, y equals something. Here it's saying, let's look at this region here first. So here it's saying move along parallel to the x direction. So you're moving along like this. You're moving along parallel to the x-axis. We have no idea what's going on, so let's just draw this line, x equals y, x equals y. So that's this thing here. So this is y equals x, same thing. It's saying move parallel to the x-axis, move parallel to the x-axis, move parallel to the x-axis, but start at x equals 0 and stop at the line. So it's saying this, start at 0 and then stop at the line. Start at 0, stop at the line. But you must move parallel to the x-axis. Start at 0 and stop at the line. Start at 0, stop at the line. But then you're scanning all the way through from 0 to 1. That means you're scanning like this. You're scanning like this. You're scanning from 0 to 1. So let's just say 1 is here. Let's just say 1 is here. Because you're scanning from 0 to 1. So you're doing this. Hang on. So really you're looking at this region here. You're scanning from 0 to 1. So this region here is talking about this region here. Okay, so now let's look at the second region. So hang on, let me clear this up. The second region. So let's look at the second region here. We have no idea what's going on here, so let's just sketch this graph. X equals 2 minus y. So let's rearrange it to make y the subject. So intercept of 2, gradient of 1. So intercept of 2, sorry, gradient of negative 1. Intercept of 2, so this will mean 2. 1 is here, not to scale, so it will look something like this. Okay, and then it's saying move, hang on, let me clear this up. So this line here is y equals 2 minus x. That's this line here. And then it's saying move parallel to the x-axis, so you're moving along like this. You're moving along like this. Hang on. You're moving along like this, parallel to the x-axis, parallel to the x-axis. But it's saying start at 0 and then stop at the line. So it's saying start at 0 and then stop at the line. Start at 0. Well, by right it should be like this. Start at 0, stop at the line. 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 But it's saying scan from y equals 1 to 2. So it's saying scan like this from y equals 1 to 2. So what it's saying is saying this. Start at 0, stop at the line. but scan from 0 to 1, scan from 1 to 2, sorry. So it's saying start at 0, stop at the line. Start at 0, stop at the line, but only scan from 1 to 2. So we're moving along like this. Start at 0, stop at the line. But we're scanning from 1 to 2. So the second region is this region here. Okay. So we've got two regions, 1, 2. But now you can combine the two by scanning in terms of, instead of dx by dy, do it as dy by dx. So you're scanning like this. Start at this line, scan up. Start at this line, scan up. Start at this. This is getting busy. I'm going to move down here. So this diagram will look like this. This diagram will look like this. Will look like this. So it's saying instead of doing it dx by dy, meaning you scan like this. One region is this. You're scanning. This is the first region, and then the second region you're scanning like this. But rather than scanning in terms of dx, let's scan in terms of dy. Dy then dx, which will mean this. Do it like this. The whole region, the two regions can combine together into one. Look, it's much easier by doing it dy, which means you move parallel to the y-axis, and then scan all the way from 0 to 1. So do it with dy then dx. So if you're doing it dy first, you start at this line, which is this diagonal line, y equals x, and then you stop at the other line. This is the other line. You start at the this line, and then you move to the second line. You start at the first line, you move to the second. Start at the first, but scan from 0 to 1. So scan from 0 to 1. So the point is that you can combine those two regions into one region here. So all we need to do now is to evaluate this this double integral. So the volume is given by this double integral. So now looking at this inner integral, integrate it with respect to y. So treat this as a constant. So constant and then y. And then integrate it with respect to y. That will then give you this. And you're doing it from x to this thing here, x to this thing here. So now put this into the y. That will then give you this thing here, and then put this into here. That will then give you this thing, and then you take away, put this into here. That will then give you this, and then put this into here. That will then give you this. So now it's just a matter of tidying this up. Let's multiply this out. That will then give you this. You might have the urge to multiply this out, but this is actually quite easy to integrate. We will see later. But now tidy everything up. Wait, if you multiply this out, it will then give you these two. So we are currently here at the moment. So now, hang on. So now combine these to the power of 3. That will then give you this thing here. So you can tidy up the whole thing, and that will then give you this. So now it's just a matter of integrating it with respect to x. So integrate this will then give you this. Integrate this will then give you this. When you come to integrate this, you're looking for something in such a way that when you differentiate it, it gives you this. Well, let's make this to be your initial guess. Make this to be your initial guess. It's going to be one notch higher. So when you differentiate this, it would be 4. The bubble stays the same. The power gets minus by 1 times by negative 1. That will then give you this, and then you would go back here. You don't want this negative 4, so put a negative 1/4 here, but you want a third here, so times a third. So that will give you this thing here. Well, do whatever you want. You should be able to integrate this by now. So integrate it. It will then give you this from 0 to 1, from 0 to 1, and and then you put 1 into here, you put 1 into here, you put 1 into here, and then you take away, put 0 into here, which will disappear, put 0 into here, which will disappear, put 0 into here, which will not disappear. It gives you this thing here. Well, anyway, blah blah blah, your overall volume is given by this. Okay.